Assalamu alaikum. Our lesson today is called the directed angle. This is the first lesson in trigonometry. What's the meaning of angle at first? Angle means union of two rays with the same start point. If we have two rays, ray AB and ray AC, the two rays have the same start point. Then the two rays form an angle. This angle is called angle BAC, or we can name the angle by another three letters, but put the vertex in the middle. The vertex is A, put A in the middle. So we can read the angle as CAB or BAC. This is the meaning of angle. What about the meaning of directed angle? Directed angle is an angle but has a direction. How can we know the direction of directed angle? We know the direction of directed angle by this arrow. Look at this arrow. This arrow is coming from AC. AC is called initial side of directed angle. Initial side. And this arrow is going to AB. So AB is called the terminal side of directed angle. So the direction of the angle from initial side to the terminal side. How can we name the directed angle? We name the directed angle by two ways. The first way is opening ordered pair. In the first, we write the name of the initial side. The name of the initial side is AC. Don't say CA, because ray, we name the ray starting from the start point. The start point of the ray is A. So the ray is AC, not CA. So the name of directed angle, we start by the initial side. And the second, we write here the terminal side. The terminal side is AB. This is the first way to name the directed angle. We start right here, the initial side, and after that we write the terminal side. We have another way to name the directed angle. We can name the directed angle by also three letters, but we put the vertex in the middle and we must start from the initial side. So the name of this directed angle is angle CAB. CAB. Don't say BAC, because this directed angle, its initial side is AC, so you must start from C. Another example to name the directed angle. Here we have directed angle. We can know the initial side from this arrow. This arrow is coming from MN and going to ML. So when we name the directed angle by this way, ordered pair, we put at first the name of the initial side. The name of initial side is MN. So we write here MN at first. And after that we write the name of terminal side. The terminal side is ML. Or we can name this directed angle by three letters and we put the vertex in the middle. Don't forget to start name the directed angle from the initial side. You start from N. NML. You put the vertex in the middle. NML. Don't say LMN. It's wrong. Okay. Another point in the directed angle, the direction of the arrow. The direction of the arrow refer the direction of the angle. Look, we have two directions. This is a clock, okay? And the clock direction is this direction. This direction is called clockwise direction. And the other is called anti-clockwise direction. Look at this arrow. In the first example, look at this arrow. This arrow, its direction is anti-clockwise. The direction of this arrow is anti-clockwise. If the direction of the directed angle is anti-clockwise, so the directed angle, its direction is positive. Also here, look at this example. The direction of this arrow is also anti-clockwise. If the direction of the directed angle is anti-clockwise, this direction is positive. The directed angle has two measures. One of them is positive and the other is negative. We see the details after a few seconds. Look at this example. To name this directed angle, we have two ways. At first, we write the name of the initial side. The initial side is ZX. And after that, we write the name of the terminal side, which is ZY. Or we can name this directed angle by 3 letters, and don't forget to start from the initial side. So the name of this directed angle is angle XZY. XZY. The direction of this angle. Look at this arrow. This arrow, its direction is clockwise direction. Clockwise direction. If the direction is clockwise, so this angle, its direction is negative. I said before, any directed angle has two measures. One of them is positive and the other is negative. Look, this directed angle, if its measure is positive 60, okay, because this direction is anti-clockwise. Type, how can we find the negative direction of this directed angle? I said before, any directed angle has two measures. One of them is positive and the other is negative. How can we find the negative measure of directed angle? To find the negative measure of directed angle, we make the directed angle minus 360. Again, to find the negative measure of directed angle, we make this angle minus 360. In this example, if we want to find the negative measure of this directed angle, we make this angle 60 minus 360. The result will be negative 300. So the negative measure of this directed angle is negative 300. Another example. If the measure of this directed angle is 100, and because the direction of this arrow is clockwise direction, then the direction is negative. We want to find the positive measure of this directed angle. How can we find the positive measure of directed angle? I said before, to find the negative measure, we make the angle minus 360. How can we find the positive measure? To find the positive measure of directed angle, we make the angle plus 360. And in this example, if we want to find the positive measure of this directed angle, we make this angle negative 100 plus 360. The result will be 260. So again, to find the negative measure, we make the angle minus 360. To find the positive measure, we make the angle plus 360. For example, we have an angle, okay, this angle, its measure is positive 150. So we want to find we want to find the positive measure of this directed angle. The negative measure, is negative 150. We want to find the positive measure. To find the positive measure of this directed angle, we make negative 150 plus 360. It will be 110. Okay, 210 degree. Another example, if the positive measure of the directed angle is 40 and we want to find the negative measure, We want to find the negative measure of this directed angle. To find the negative measure of this directed angle, we make this angle minus 360. 40 minus 360, it will be negative 320 degree. Okay. Now we want to find we have angle of measure 100 and we want to find the negative measure of this directed angle. To find the negative measure of this directed angle, we make this angle minus 360. It will be negative 260. Another example, we have angle of measure 50 and we want to find the negative measure of this directed angle. We make 50 minus 360. It will be negative 310 degree. Another example, we have angle of measure negative 200 and we want to find the positive measure of this directed angle. I said before, to find the positive measure of directed angle, we make this angle plus 360. It will be 160. Also, we have angle of measure negative 300. We want to find the positive measure of this directed angle. We make negative 300 plus 360. It will be 60 degree. Okay. Now we talk about directed angle in a standard position. Directed angle in standard position. Two conditions to make the directed angle in a standard position. Two conditions. The first condition, its vertex must be on the origin point. The vertex of directed angle must be on the origin point. Yani for example, we have here y-axis and x-axis. The first condition to make the directed angle in a standard position, that is the vertex of directed angle must be on the origin point. That is the first condition. Okay, what about the second condition? The second condition is initial side of the directed angle must be on positive direction of x-axis. Look at the screen. Look at the initial side. Look at the initial side. The initial side sorry. The initial side is on the positive direction of x-axis and the vertex of the directed angle on the origin point. So the two conditions satisfied, so this directed angle is in standard position. I want you to choose which of the following angles in standard position. Look at the first. Here. And the second problem. The third one. And the last one. Okay. Don't forget the directed angle in a standard position if it's a vertex on the origin point. And the second condition is initial side on positive direction of x-axis. Look at the first example. Is this directed angle in a standard position or not? The first condition satisfied, its vertex is on the origin point. But the second condition not satisfied. Look at the initial side. I said before, to know the initial side, look at this arrow. This arrow is coming from this ray. And this ray is the initial side. The initial side of the directed angle in a standard position must be on positive direction of x-axis. This is not satisfies the second condition. Look at the second graph. The first condition is vertex of this directed angle on the origin point, And the second condition also satisfied. Look at the initial side on positive direction of x-axis. So the two conditions satisfied, so we can say that this directed angle in standard position. Look at the figure number 3. Oh, the first condition not satisfied. Look at the vertex here not on the origin point, because the vertex not on the origin point, so this directed angle not in standard position. The fourth figure, the first condition satisfied. Look, the vertex is on the origin point, but the second condition not satisfied. Look at the initial side on negative direction of x-axis. The second condition said that the initial side must be on positive direction of x-axis, not in negative direction of x-axis. So the second condition not satisfied. So we can say that this directed angle not in standard position. Okay. The x-axis and y-axis divides the plane into 4 quarters. Each quarter is called in Latin quadrant. This is the first quadrant. This is the second quadrant, third quadrant, fourth quadrant. If we draw directed angle in a standard position, we start to put here the initial side, and the terminal side may be here also. If the initial side and the terminal side on each others, so the measure of directed angle in this case will be 0 degree. Okay. 0 degree. The terminal side will move and stop moving here. So the measure of directed angle in this case will be 90 degree. Okay. If the terminal side continue its moving to stop here, so the measure of directed angle will be 180 degree. And if the terminal side move and stop here, so the measure of directed angle is 180 plus 90, it will be 270 degree. If the terminal side make one cycle and stop here again, so the measure of directed angle equal 360 degree, and also we can say that 360 is equivalent to 0. Equivalent to 0 because the terminal side stop at the starting point. Okay, if we want to know that 50 degree, if the measure of directed angle equal 50 degree, so the terminal side in which quadrant? Yes, because 50 is less than 90 and more than 0, so the terminal side will be in the first quadrant. If we have angle of measure 200 degree, we want to know its terminal side in which quadrant. Because 200 is more than 180 and less than 270, so this directed angle in the third quadrant. If we have angle of measure 179 degree, its terminal side in which quadrant? Because 179 is less than 180, so this directed angle, its terminal side in the second quadrant. Angle of measure 350. This angle, its terminal side in the fourth quadrant, because 350 is less than 360. If we have angle of measure negative 40 and we want to find its terminal side in which quadrant? Negative 40 means the terminal side will move clockwise direction. Clockwise direction in this direction, 40 degree. Okay, negative means the direction. Direction is clockwise, but positive measure means that the terminal side move anti-clockwise. So negative 40, this angle, its terminal side lies in the fourth quadrant. Okay, we have another method to find the quadrant of this directed angle, whose measure is negative 40. We can find the positive measure of this directed angle at first. To find the positive measure of this directed angle, we make negative 40 plus 360. It will be 320. 320 in which quadrant? 320 less than 360. So this directed angle, its terminal side lies in the fourth quadrant. Angle of measure negative 200 degree. We want to know its terminal side lies in which quadrant. We must find at first its positive measure. To find the positive measure of this directed angle, we make it plus 360. The result will be 160. 160 is less than 180. So this directed angle, its terminal side lies in the second quadrant. Okay, let's talk about the equivalent angles. 0 degree, 90 degree, 180 degree, 270 degree, and 360 degree. If we have directed angle of measure in standard position, its measure is 40 degree. Okay, if its terminal side make one cycle and stop here again, okay, so the measure of the directed angle will increase by 360 degree. If we make 40 plus 360, it will be 400. We can say that 400 equivalent to 40. 400 equivalent to 40. Because the terminal side of angle 40 is itself the terminal side of angle 400. So we can say that 400 equivalent to 40. If the terminal side make another cycle again and stop at the same point, so the measure of directed angle increase by 360. So the measure of directed angle will be 760. We can say that 760 equivalent to 400 equivalent to 40. Yani to find the equivalent angle, we make plus 360 or minus 360. If we make 40 minus 360, the result will be negative 320. We can say that negative 320 also equivalent to 40 and also equivalent to 400, equivalent to 760, and so on. If we have angle of measure, angle of measure 7,000 or 790 degree, we want to know that this directed angle, its terminal side lies in which quadrant. What can we do? We make to know the quadrant of this angle, its measure must be between 0 and 360. Okay, so we must find the equivalent to this angle, and the equivalent to it must be between 0 and 360. To find the equivalent angle to 790, we make it minus 360. If we make it minus 360, the result will be 430. Still this number not between 0 and 360, so we make it also again minus 360. If we make it minus 360 another one time, the result will be 70. Okay, now we can say that 790 equivalent to 70. 70 less than 90 and more than 0 lies in the first quadrant. Okay, so the angle of measure 790, its terminal side lies in the first quadrant. Again, if we have angle of measure 1059, we want to know its terminal side lies in which quadrant. We make minus 360, still the number more than 360. Make minus 360 again. You can make minus 360 two times. The result is 339. Now this result is between 0 and 360. 339 is less than 360 and more than 270. So this directed angle lies in the fourth quadrant. If measure of directed angle is 0 or 90 or 180 or 270 or 360, So this angle is called quadrantal angle. Quadrantal angle. Okay? Not in the first quadrant or second quadrant, not on it. Okay? This angle is called quadrantal